All right, let's crush another chemistry question. You generate hydrogen gas by reacting zinc with HCl to produce hydrogen gas and zinc dichloride. You collect the hydrogen gas in an evacuated container with a volume of 3.0 liters. If you start with 6.0 grams of zinc and sufficient HCl to complete the reaction, what is the final pressure of the gas collected in the container if the temperature is 25 degrees Celsius? So let's just take a second and look at what we're given here. So we're given a volume, some grams of zinc, a temperature, and we're asked to calculate pressure. Just given the information that we're given here, that sounds like a PV equals nRT type of question. So we're using the ideal gas law, PV equals nRT. And we're given several of these variables. We're given that volume is 3.0 liters. We're given the temperature is 25 degrees Celsius. We're asked about pressure, so that's what we're going to have to calculate. So the only variable that we're missing here that we're not trying to solve for is N, which is moles. And if we're given grams, oftentimes we can turn grams into moles by calculating that. And typically, when we calculate that, we're going to need a balanced equation. So let's create a balanced equation first of this situation. So we're reacting zinc with HCl to produce hydrogen gas, which exists as H2, and zinc dichloride. So that di is telling us that we've got 2 Cl's on that zinc. So we got to balance this equation. We can see that we have 2 hydrogens on the right, 1 hydrogen on the left, 2 chlorines on the right, 1 chlorine on the left. So if we just double this, that's going to take care of both of those discrepancies, and now we've got ourselves a balanced equation. We got 1 zinc on the left, 1 zinc on the right, and 2 chlorines and 2 hydrogens on both sides. So this is a nicely balanced equation. So now what we're going to do is some dimensional analysis to try to turn this 6 grams of zinc into moles of hydrogen gas, because the gas is what's going to dictate the pressure in this situation. So we're starting out with 6 grams of zinc, and we're trying to get to moles of hydrogen. So in order to change from grams to moles, typically we're going to want to use a molar mass, because the units on that are grams per mole. So we're going to want to cancel out grams and get into moles. So we want to know how many grams of zinc are in 1 mole of zinc. Well, zinc's molar mass is 65.38 grams per 1 mole of zinc, which allows us to cancel out the grams units, and now we're in moles units. But we want to be moles of hydrogen gas, so now we have to use our balanced equation to get from moles of zinc into moles of hydrogen gas. Well, it looks like that's a 1-to-1 ratio in our balanced equation. We've got a 1 over here, we've got a 1 over here, and a 1 over here in front of both of those compounds. So we can say that there's 1 mole of zinc for every 1 mole of hydrogen. Cancel out these units, and now we're in moles of hydrogen, which is exactly what we're looking for to enable us to do our PV equals nRT calculation. So we just need to calculate this dimensional analysis. We'll multiply what's on top, divide by what's on the bottom. That's going to give us 0.0918 for our moles of hydrogen. Typically when we do these calculations, we want temperature to be in Kelvin. So in order to put Celsius and Kelvin, I have to add 273 to our Celsius to make this Kelvin. So that's going to give me 298 Kelvin for our temperature. Now I can plug all of our information into our PV equals nRT equation. So again, we're solving for P. So we got P times our volume, which is 3. It's going to equal N, which we just calculated as 0.0918. Then we've got to plug our R value in, which varies depending on what we want our unit for pressure to be. I'm going to use the R value that gives us atmospheres. So the atmosphere's R value is 0.0821, and that's just a constant. That's just a number that we know for R. That's always the same. And then times our temperature, which we just converted into Kelvin, and that's 298. So to get our pressure, we're just going to multiply all these numbers, divide by 3 to solve for P. And after all is said and done, after we calculate that out, we get a pressure of 0.749 atmospheres.